Hello and welcome to this video. In it, we show how to move a Rimol Greenhouse's incorporated movable feast high tunnel from one plot of land to another. The video is a little less than 9 minutes long, and in that time you will see the tunnel moved from the right to the left in your field of view. That is a distance of about 70 feet. Since the tunnel is 30 feet wide by 50 feet long, in this case, the tunnel will move a distance that is roughly equal to 1.5 times its length. The tunnel will not move sideways. However, if enough turning space was available and the right technique was used, the tunnel could be situated left or right of where it sat previously. That's important to keep in mind. The tunnel was in the position on the right for 1 year, from August 2015 to August 2016, and it will be in the position on the left for 1 year until August 2017. The camera position will not change during the video. So, text that supplements what I say appears from time to time in the lower part of the frame. That text contains specific important content. Of course, you can pause and rewatch the video as often as you like. 4 people appear in the video and they complete specific activities. My name is Matt Kleinhans, and in the video I am in a light colored shirt and I move around quite a bit, checking this and doing that. Sonia in red and Julie in white manage the winches that move the tunnel. Terry assists me with miscellaneous tasks. We are filmed by Mike Merritt of Rimol Greenhouses Incorporated. We filmed the entire move, which took 20 minutes. However, we reduced the length of this video to 9 minutes by clipping sections where nothing significant was happening other than the tunnel was moving steadily right to left. So the video skips occasionally, but everything that is important to see is included. Beyond the people and cordless drills, the workhorses of the move are the geared winches that are attached by cables to the tunnel. Each winch is attached to a post in the ground. Let's spend a minute or two talking about the cables and their preparation and management during the move. The first thing to notice is that you can't see the cables in the video. Well, rest assured they are standard steel cables, widely available and easily connected to the winch and high tunnel. Also, we try to keep the tension on the cables similar during the move. The tunnel can take some torsion or twisting. However, it is best to keep the tunnel square while it is moved and to have it square when it is set in place. We take 4 steps to help keep the tunnel square while we move it. These 4 steps should be part of any high tunnel moving process like the one shown in the video. First, we mark the cables with orange spray paint. You can decide the interval at which you place marks, but we used 4 feet during this move and it worked out okay. In the future, we may shorten the marking interval to 2 feet. Second, we check the tension on the 2 cables every so often by pushing down on them. Third, Sonia and Julie coordinate their progress in 2 ways. 1, they count orange marks on the cable as it collects at the winch. And second, they winch separately or at lower rates as needed. As the 4th step to keep the tunnel square while we move it, we attach 3 standard batten straps at different points on the tunnel before beginning to move it. 1 strap is placed at each end wall at the inside of each door frame. The 3rd strap connects the center bows of the tunnel. All of the straps add support during the move. However, the center strap is especially important because it also keeps the tunnel close to its ideal width of 30 feet. That is important when setting the tunnel in its new location. Earlier, I mentioned that we push down on the cables to check their tension. Well, actually, we push down on the cables at different places, and for 2 reasons. Closer to the tunnel, or midway between the tunnel and winches, we push down to check the cable's tension. Closer to the winches, we push down to help spool the cable evenly. Like winding kite string, the cable should be distributed evenly and not allowed to collect at one end of the spool. You want to avoid that for 2 reasons. First, too much cable at one end may make the final feet of the move more difficult. Second, uneven spooling also changes the rate at which cable collects and the tunnel moves on one side. In this video, Jenny helps Julie near the end of the move by pushing down on the cable as it nears the winch. Now let's spend a minute on the 10 wheels used to move the tunnel. Well, each wheel inserts to the bottom of the sidewall at preset locations. Also, each wheel and axle there's actually a wheel and axle unit. Each unit has an extension that allows the wheel axle unit to also serve as a lift point for raising the tunnel to attach the unit. Pressing down on a hollow metal bar that is slipped over the extension lifts the tunnel so the axle can be secured with a clip. Also, the wheels and tunnel can go over rough ground. However, we prefer to make a smooth path for each row of wheels to make the job easier and to put less stress on the tunnel. At one point in the video, I use a shovel to move soil from one place to another on the left uphill side of the tunnel. I did this to fill a hole in the path of the wheels on that side of the tunnel. The hole was behind the first wheel and in front of the remaining 4 wheels. We had created it months before to snake irrigation lines into the tunnel, but we forgot to fill it before starting to move the tunnel. As you watch the video, also keep in mind that the tunnel is situated in a field that has a slight grade. We have moved the tunnel once before in 2015, and it tolerated that move very well. Thanks partly to the wheel-based moving system, I am confident that the tunnel could tolerate moves across even steeper grades if needed. Overall, as you see, Sonia and Julie move the tunnel using geared winches. Sonia and Julie power the winches either by hand or with cordless drills. The ladies crank by hand in the first part of the video, and they use cordless drills in the second part to complete the move. You will want to notice how easily the tunnel moves either way. You will also want to notice that the tunnel moves more quickly by drill than by hand cranking. That is true for 2 reasons. First, in this case, we began the move by hand cranking. Therefore, the spool that collects the cable that connects the winch to the high tunnel was empty. As cable collects, each turn of the winch pulls more cable and the tunnel gains speed. Second, everything being equal, the winch can be turned more quickly with a drill than by hand. Regardless, remember, once the move started, it took only 20 minutes to complete. It would have taken less time, but we were not in a hurry, and we checked the condition of the high tunnel often. Terry, Julie, and I also position ground cover in the path of the wheels. We do this so that when the wheels are removed and the tunnel is lowered to the ground, the tunnel sits on the ground cover. This helps us keep the perimeter of the tunnel clean and weed-free. Finally, Terry and I also check the width of the tunnel several times. We check the width at various locations along the tunnel, beginning in the middle. A yellow bat strap connects the 2 center bows. We check the distance between these bows during and after the move to make sure it is as close to 30 feet as possible. At one point, the strap is repositioned lower on the bows and then retightened. After the video ends, the wheels were removed and the tunnel was set down. Then I used a spud bar and a little effort to bring the sidewalls to the tunnel's ideal width of 30 feet as measured at multiple bows. A helper measured while I moved the sidewall at various points. When the tunnel was lowered to the ground, the width had increased only 2 to 3 inches in some places. Otherwise, the sidewalls were straight, so the job was easy. The video depicts nearly the entire process for moving this tunnel from one position to another. The tunnel could be moved farther if needed. For example, one could use tractors or vehicles instead of posts and winches, or one could use longer cables or do the job in stages. Either way, text inserts in the video provide additional information on preparing for and completing the move. In our experience, the entire job can be done between breakfast and lunch or between lunch and dinner. You may be considering the pros and cons of working with a movable high tunnel. You may wonder how a tunnel can be held firmly in place when it needs to be, but also moved to another site fairly easily without too much effort, time, or money. We have had virtually no trouble with the stability of this tunnel in our conditions. Also, as seen and heard before, the entire job of moving the tunnel from preparation to moving to securing and reassembly can be done in well less than a day by 2 to 3 people using a few standard hand tools. Thank you for watching the video. I hope it was useful to you.